or you can call and it will install all the tools that come with it. Maybe you already done this in a way. So for example, if for those who've been working with tools like for SARS-CoV like Pangolin, you've run those commands. Maybe you didn't think a lot about it, but essentially you come across these YAML tools and export the specs into an existing environment to a YAML file and create a new environment from that file. Okay, so I think that's the end. And Phil is given us here a really nice lecture. I would really ask you to go through it. From Anna Price, Cardiff, that's a CLIBE network, and she goes in quite some details about Conda environment and a really nice YouTube video. And I'll provide you a really nice overview of Conda, and actually an entire practical that you can follow quite easily. And open source software packaging for science, that's another link, and the Python virtual environments. I did mention about PyEnv, and that again can provide you with a way to have isolated sandboxes and manage, for example, Python versions. Right. So that's the end of that. Any questions, maybe? Discussion points?
Yes, a question.
Yes. Yeah.
So you mentioned something to do with sandboxes.
Yeah.
Yeah. So I've come across that a few times. What does that mean? What does that mean? A sandbox.
I'm just using that word in its meaning. So it's a way to I think it's a term people use to think about isolated environments where I just want to do something here without thinking about the outside, and it's a sandbox in the sense that I have sort of boundaries, and I just want to work within that, and it's something that I can get rid of quite quickly. I don't know what the dictionary meaning of a sandbox is. Yeah.
It's like a testing environment.
Yeah. Yeah. It's
a testing environment.
Yeah. It's So it's a way of isolating. You can think about an isolated environment, and you can do your things in there. It's sort of specific to that environment, and you can then get rid of it later. Possible?
Maybe I can just say,
yeah.
It's just a garden, a small garden inside another garden. You can plant whatever you want to plant in there, and if it doesn't work out, then you can just get rid of that environment.
Just give me that.
Yes.
So
the analogy I think is drawn on, I think if you have children, you can make a sandbox where they used to play.
Mm-hmm.
And the way that you set that up is it avoids messing up for the child. That instead of taking them, say, to the beach where there's sand, you can have your own containerized sand where the child can play. Maybe you don't have, it's like a playbox.
Yeah, thanks. That's clear now? Yes?
You've shown us some things which, for me, are confusing. There's Conda, there's Anaconda. Anaconda is, you've already explained about Anaconda. And there's Miniconda, there's virtual environment, there's mamba. So can you help me to differentiate those environment and what the differences? What the difference between Conda and Miniconda, mamba, whereas mamba and PAP also?
Yeah. Well, there's only so much I can go into, but so I'll give it a shot, and then maybe someone from the audience can try. So you got this idea. So again, just going back to what the problem was way back. So we are here, okay, and we want to resolve this. This is our big challenge, okay. So a bunch of clever people or clever communities came out with idea on how to get around here. So they've simplified that diagram and they've outlined specs, and they have identified what the problem is. So the question is, what are we going to do about this? Okay, so the problem is, I got a software that I want to install, okay? But that software depends on another software, or multiple softwares, which then depend on other softwares, which then depend on something, which depend on something, okay? So the question is, if I want to install this software, how do I deal with this dependency hell? Okay, how am I going to deal with it? Okay, and because they are clever people, clever communities, they thought that we're going to come up with a distribution, or we're going to develop a tool that will simply contain Python and R and all the packages, because R is another, I'm not going to delve in here, but that's a whole different problem there. Okay, and it's going to try and do a couple of things. One, make the tooling available, make it possible to install software, make it possible to create these sandboxes inside your computer, because it's the only way to deal with the dependency hell. Okay? And the way they thought about it is they called the tool Anaconda. Okay, I think just, you know, I understand these are Amazon really big fish. Oh, sorry, snakes, not fish. Like they're really, really huge snakes, okay? And I think they got inspiration from Python itself, you know, like the snake, okay, the snake language. I got no idea why they call it Anaconda. They could have named it whatever. Then it turns out that doing this and having this installation, if you, we're just going to go to the internet, it's quite large installation. Often that you don't need all that tooling, okay? So you create a minimal version and you call it Miniconda. So the Miniconda is a minimal version of Anaconda, yeah? And it's just going to contain Python and it's going to contain Coda. Now, circularity, isn't it? So it's going to contain this Python, which is the language, and Coda, which again is a tool, right, that you can use to install software and manage your environment. So I think it'll get more clearer when you get to the practical bit of it. Okay, mamba. So it turns out that Coda, of course, Coda is a tool, right? And it just became too successful, or very successful, if you like. Okay, and you know, it ran into some headwinds, and therefore you got to think about how do I make it better. Okay, so often in the software world, if you've ever written software, you know that, and particularly community software, if you want to make large drastic changes, you run the risk of breaking things, and people will not be happy with it. That's what also happened with Python 2.7 and Python 3. Okay, you got to update things, you got to upgrade tooling, but that does not necessarily make the community happy. And sometimes you got things that are so much dependent on the old way, and therefore moving those over to the new way of doing things becomes a challenge. Okay, and therefore, rather than continue trying to work through Coda, they just wrote another tool. They called it Mamba, and it's a drop-in replacement. It can do everything that Coda does, and it's going to use sort of the same familiarity. So you're just going to replace where you said Coda, you just say Mamba. Okay? But then it turns out that this Mamba thing, this new tool, is all nice and optimized and lightweight, I presume. Okay? So that's the difference between Coda and Mamba. Okay? And the way to install Mamba is through Coda. So you have to set up the Coda environment and then install Mamba in it. It doesn't sound so, yeah? Is it a little bit clearer now? Yeah, okay? Yeah, so it's all ways of resolving the problem that we have, and obviously there are other ways of doing this, but a lot of the bioinformatics community have come to rely on this a really nice environment. And I think very much appreciate the developers and people who spend tons of their time looking through and writing these tools for the community. Yeah. Okay. So I'm going to try and pull out. So I don't know whether it's very visible. So the other thing we're going to do, and what Phil and I had discussed, is that we're not going to do a lot of reinventing the wheel. Instead, we will rely on a lot of other, one, we're going to rely on material that's already on the internet, and if there are tutorials on the internet, we're also going to pull from them rather than rewriting everything afresh. Okay, so I'm just going to go through this, and I think, yeah, you can try, but I don't know, Edwin, is it at this point? Can I go through this and maybe you can now step in and then tell us about how our environment is set up and how we log in, and then we ensure that everybody is sort of logged into the cluster. Maybe at 12, and then we can spend maybe the next hour before lunch trying to get around the tutorial. So I'm just going to pull out the tutorial that Phil wanted us to go through, which was installing Miniconda, installing Mamba, installing a tool like some tools and a couple of other things. And I think we got internet accessibility, so maybe again you can use that. But this is just meant to, acquaint us with this great environment. So I think this just pulled out installation. So this is the Conda webpage, Conda.io. Maybe I can just go here. There used to be like another one called Anaconda, which is a much larger install. But if you just go to Conda.io, you see all the details. And what we're interested in here is sort of, and yeah, well, I'll come to that. It's sort of the, how to install, which is under the user guide, right? So you got all the details here, and you can move on to, very specific details. But what I wanted us to go through is, how to install. So largely, I'll just walk through Linux. Most of what works on Linux can work on Mac OS, quote unquote. But it might not necessarily work on Windows. And I believe that most of us work on Linux systems. Anyone who works just on Windows? Who does all their development on Windows? No one. Wow, that's a happy place. So I can now just work on Linux. Right. So essentially, you can download the installer for Linux, and you can also download the Anaconda version. I don't know whether there's a way for me to make this a bit larger, maybe. Yeah, like that. Yeah. And if you just want to install a Miniconda by running this command and trusting that this script does what it's intended, which is just to install. So there's always, whenever you see somebody telling you to install software like this without, running this command, it's always nice to double check this command or the script. It's just a bash script, but I think we can trust what the developers here are telling us, that this script will just install Miniconda and not do anything to our system. And this is again what you can do. So you download it and then you run bash, which you're calling the bash shell, and you're giving it the .sh script. And what it will do is that it will ask you a couple of questions, but then essentially it will download, it will install the Conda environment, the Miniconda environment. Yeah. So it just says step 4 there, follow the prompts on the screen. Should be easy. And to make changes take effect, close and then reopen your terminal window. Essentially, that will just refresh and update your path. Test your installation. In your terminal window or Anaconda prompt, you want to run coda list. So a list of packages appears if it has been installed correctly. So I got a coda environment here. Don't want to use this one, it's on the server. I can do a new window here. Yeah, so this is how it will look like, just to, if you, after you run those steps and you run successfully, you see a command base. Yeah, and if I run coda list, you can see a bunch of tools that's already installed. Some of these, they are installed as part of resolving the dependencies. So I got quite a wide range of tools that are installed. Okay, and you can see that you got a build, and the build has a sort of a hash onto it, and you can see where they are coming from. This is the channel, right? So that's CodaForge. This is coming from Pipey. This is coming from CodaForge. And essentially, what I've done there is that I've done one of those canonical mistakes where I've actually sort of installed some tools on my base environment, which is not what you should be doing. But yeah. So over time, people make improvements, and the world of software, there are always tons of alternatives. So Bash is really awesome, really nice. But there's this new shell called Fish, which is just like Bash, only a bit more awesome. And they can do something, and the developers have shown you how to get around doing the installation. And if you want to update Coda, you run Coda update Coda. So it can update itself, okay? Which you want to do every so often, okay? And if you want to remove it, it's really easy, it's Miniconda gets installed in your home directory, and then the path gets prepared on your path, and you can just the rm command -r recursive and then force Miniconda. Okay, so the rm command is the Linux command for removing, deleting stuff. The r -r says recursive because it's a directory, and f for force. Yeah, so that if you require any restrictions, you can just run it, and of course you can optionally edit this, and so on and so forth. And again, I think these are all optional if you want to completely clean your environment. Okay. Yes.
When I still run my assignments using either Anaconda or Miniconda, or they must be both?
No, you only need one. Yes. So if you choose to go with Anaconda, it's a really large install. If you're bioinformatician, I'll go more for Miniconda. It's just easy to install, run things, and you don't have to have a bloated software. So Anaconda is really large and has tons of tools that it's pulling in. So be nice, why do you want to do it? And if you've got a nice, good use case, then go for it. But you only need one of either. Right? Correct, possible? Yeah.
Yeah, so think of like Anaconda as the mothership. It's massive. It might need 100 gigs, and some institutions don't have that much disk space on their computer. So they can't install such a big software. So what the developers do is they make a smaller version, so the micro version. So that's maybe a third of the size of the mothership. So by installing the smaller version, you can pretty much do everything Anaconda does, but you have less software or system requirements, so that you don't need a fancy system.
Great. And down here you got all the tooling you need. Downloading, how to install on Windows, if you're on a Mac OS system, Linux, which we've just gone through, all if you're on a Debian system, and there are all the Debian repositories, and if you're on sort of Red Hat, you got all your RPMs that you can set up. And more important, maybe we come down to that, is there is a cheat sheet that you can always use. Let me see where that is over here. Yeah, maybe we'll come down here, but yeah, so I will just invite Edwin, just to let us know, and then we'll come down to this, and then we'll run the practical, and again we can assist each other. Great if you've already done this before, and you can help your colleagues. I don't know what's the best way to do this. Should I send this assignment to you and share with everyone, or I'll just put it up here? Anyway, I'll just put it. Yeah, Edwin, please.
So, George, will this material be available to us?
Which one?
Like slides?
Yes, the slides and everything will be available, and
Yes,
there'll
so
be a
we
recording.
have recorded everything, so we'll make the slide available. You can have the videos, so you can also watch them, go through the audio, go through all the presentation at your own time.
Already distributed. Good job.
We will probably email the link, so we will also need to upload this as well. You guys can see it. I'm not in it.
Right. So, do you want me to get in this? Edwin is a system administrator and manages our Linux cluster. So, Edwin, you just go through what you set up and how to access the terminal. I think that will be great, and then we can help everyone just ensure that they've all accessed the terminal. And then I think you've got Conda installed and so on, but yeah, go on, Edwin.
Yeah, so first of all, I told you to access the server. Now the server IP, the one that is displayed here, I think you can write it somewhere. And then in that server, we have created users. We have around 25 users created. So here we have SSH, you use SSH, but these machines are installed with Windows. There's a tool called PuTTY already installed. So you can just search PuTTY in your Windows machine. If you're using Mac, then you can just type SSH. You can open your Mac terminal and then you just type SSH. Now, we have several users. Here we have trainer one, train one. Now we have 1, 2, 3, train 1, train 2, train 3, up to train 25. So it is good that you use different, every one of you uses different user so that you, when you install something, don't conflict. So we are going to take, each one of us is going to take one user who is already installed, who is already created in that machine, and we are going to use that user throughout the week. So, we are going to take users from train 1 up to the end. So I think I start with that here. You take train 1, train 2, train 3, 4, 5, 6, 7, 8, 9, 10, 11, the yellow, yeah, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you replace train 1 with your number. So if you are number 11, just put train 11. Train 12, train 5, whichever, and SSH to that machine. Now, the password, we have a common password. I write it here.
Yeah, go on.
So
Very secure password.
it is not secure. But, it is going, you are going to make it secure yourself.
the first time you use that password, you are going to be asked to change it and give yourself your own strong password. So if you give a weak password, it will not accept. So just put a minimum of 8 characters, special characters inside there. If you put a weak one, it will not accept. So your initial password is that one, and then you are going to be asked to change. Permission being made. So even an error saying permission being made. When you are set or when you put the password? Yeah, put a strong password. A very strong one.
You might as well write it down, then it defeats the purpose. Yes, please.
Actually, I could do some of these things already on my laptop. Are we going?